Dying? Yes, you heard it right. Voyager 1 is dying, not with a crash, not with an explosion, but with a slow, quiet fade, the way a candle burns down to its last flicker, or a heartbeat grows faint before it disappears. 48 years ago, we sent a message in a bottle to the stars. Today it's still sailing, farther than any human object has ever traveled. But its power is running out. One by one, its instruments are being switched off, never to wake again. The question is not if it will fall silent, but when. And how far will it have traveled before its final whisper leaves us forever? This is the story of Voyager 1, the farthest, fastest, and longest-lived ambassador from Earth. And its journey is just beginning, even as its voice begins to fade. What has Voyager 1 accomplished? But before we talk about its death, we need to understand what it has achieved. Because Voyager 1 didn't just drift into history, it earned every mile. On September 5th, 1977, Voyager 1 began its life, not with a cry, but with the thunder of a Titan rocket. It was born to explore. Its mission, to study the outer planets. Giants no spacecraft had ever visited up close. But the journey almost ended before it began. The Titan rocket's second stage shut down prematurely, leaving unburned propellant. The Centaur upper stage compensated with an extended burn, nearly exhausting its own fuel. Voyager 1 survived, pushing onward. It met Jupiter like a giant welcoming its first guest. On March 5th, 1979, it swept within 349,000 kilometers of the planet's clouds, capturing images that revealed swirling storms, a thin ring system, and moons like Io, where active volcanoes erupted for the first time ever seen beyond Earth. Then came Saturn. On November 12, 1980, Voyager 1 danced with the ringed planet. It discovered complex structures in the rings, shepherd moons sculpting the ice, and Titan, a moon wrapped in a thick, hazy atmosphere, hinting at the chemistry of life. But then, something unexpected. Instead of continuing to Uranus and Neptune, mission controllers chose to send Voyager 1 on a different path, one that would take it close to Titan. That decision cost it the outer planets, but gave it something greater, a trajectory that would fling it out of the solar system forever. It left its planetary family behind, and it never looked back. In 2012, Voyager 1 crossed a threshold no human object had ever crossed. It left the solar system. The wind of the sun faded. Why the particles around it changed? For the first time, it was truly alone, surrounded only by the cold, ancient space between the stars. It became the first human-made object to taste interstellar space, and it kept going. The heartbeat, what keeps it alive? Voyager 1 doesn't run on sunlight. Out there, the sun is just a bright star. Instead, it carries its own heart. 3 radioisotope thermoelectric generators, or RTGs, small nuclear batteries containing plutonium-238. At launch in 1977, they produced about 470 watts, enough to run a few light bulbs. The heat from decaying plutonium is converted into electricity. No moving parts, no refueling, just a steady, silent heartbeat that has kept Voyager alive for nearly 49 years. But that heartbeat is slowing. Plutonium-238 has a half-life of 87.7 years. Every year, the RTGs lose about 4 watts. It's like a slow leak in a vital artery. By early 2026, Voyager 1 is operating on roughly 200 watts, barely enough to keep its computers, its transmitter, and a handful of instruments alive. Engineers at NASA's Jet Propulsion Laboratory have become masters of triage. Non-essential heaters were shut down years ago. Science instruments have been powered off one by one. Sacrifices to keep the core alive. The planetary cameras went silent after the 1980s flybys. The plasma science instrument, 2007. The ultraviolet spectrometer, 2016. The cosmic ray subsystem, February 25th, 2025. Later in 2026, the low-energy charged particle instrument will be turned off. Soon, only 2 sensors may remain: the magnetometer, listening to interstellar magnetic fields, and the plasma wave subsystem, sensing the faint oscillations of space itself. Every shutdown is a deliberate act of mercy, choosing which senses to sacrifice so the probe can keep its eyes open just a few years more. The real threat, silicon dioxide. But fading power isn't the only danger. There's another threat, more immediate, hiding inside the spacecraft's own fuel system. Voyager 1 carries hydrazine fuel for its thrusters, the small rockets that keep its antenna pointed at Earth. But after 49 years, a rubber diaphragm inside the fuel tank has been slowly breaking down. The byproduct is silicon dioxide, essentially microscopic glass beads, and they have been clogging the thruster fuel tubes. These tubes were already tiny. Originally, they were 1/4 of a millimeter wide, about the thickness of 3 sheets of paper. Today, some are clogged down to 0.035 millimeters. That's half the width of a human hair. In 2002, engineers noticed the first set of thrusters clogging. They switched to a backup set. In 2018, that set began clogging too, and they switched again. Now in 2026, even the third set is failing. But NASA's engineers have refused to give up. In 2024, they pulled off a risky maneuver, swapping back to the original thrusters, the ones that had been sitting cold and dormant for over 20 years. To do it, they had to turn off one of the spacecraft's main heaters for an hour, freeing up just enough power to warm the old thrusters before firing them up. It worked. Voyager 1 is still talking to us. The freezing threat. Another enemy, fading power isn't the only danger. There's another threat, more immediate, lurking in the cold. Voyager 1 carries hydrazine fuel for its thrusters, the small rockets that keep its antenna pointed at Earth. Hydrazine freezes at just 2 degrees Celsius, barely above freezing. As the spacecraft grows colder, engineers watch the propellant line temperatures with growing concern. If the hydrazine freezes, it won't just stop working. It could destroy the thrusters from the inside. When hydrazine freezes, it contracts, the opposite of water. More liquid flows into the void, freezes, contracts again. If it ever thaws, there's more fuel in the pipe than it was designed to hold. The pipe bursts. The thrusters are gone forever. NASA's engineers have become masters of this delicate balance. Turn on a heater to keep the fuel liquid. That uses power. Turn it off to save power. The fuel gets colder. Every decision is a gamble played out across 23 light hours of distance. In 2024, they faced their toughest test yet, a thruster fuel tube clogged with age, silicon dioxide from a rubber diaphragm that had been decaying for 47 years. To switch to a backup thruster, they had to warm it first. But warming it meant turning off something else. They found a way. They always find a way. But each time the margins get thinner. Yet even as its power fades and the cold closes in, Voyager 1 shows an almost willful determination to continue. It doesn't complain when its thrusters clog with decades-old residue. It doesn't falter when a memory chip corrupts or a heater fails. It simply adapts or lets its human caretakers find a way. In 2024, when its flight data subsystem fell silent for months, engineers performed a miraculous remote surgery across 23 light hours of distance. They rewrote code and relocated software in its tiny, ancient computer, a machine with less memory than a modern car key. The spacecraft woke up and resumed its steady march outward. This is more than survival. It is a kind of quiet, unbreakable will. Voyager 1 wants, if a machine can be said to want, to keep going. It was forged with that singular purpose, to explore, to endure, to carry humanity's message beyond the sun's protective bubble and into the galaxy. Today in March 2026, Voyager 1 is 172.59 astronomical units from Earth. That's about 25.8 billion kilometers, 16 billion miles. The farthest any human-made object has ever traveled. It moves at 17 kilometers per second, 61,000 kilometers per hour. At that speed, you could cross the United States in 3 minutes. But in the vastness of space, it's a slow drift. It gains 3.6 astronomical units every year. Radio signals travel at the speed of light. Yet even light takes over 23 hours to reach Voyager 1. A command sent from California today will arrive tomorrow. The reply won't return until the day after. In November 2026, Voyager 1 will hit a symbolic milestone. 1 full light day from Earth. A 24-hour journey for light. A 48-hour round trip for a command in its response. Will it die? So how much longer can it keep going? The answer lies in those RTGs. Engineers project that the power will still be enough to keep the spacecraft's engineering systems, the computer, the transmitter, the ability to point its antenna at Earth, until somewhere between 2030 and 2036. By then, the Voyager 1 will have coasted another 36 astronomical units farther, reaching roughly 208 astronomical units from the Sun. Still well inside the Oort cloud, that distant shell of icy bodies surrounding our solar system, but far beyond any hope of rescue or repair. As the watts drop, the signal grows weaker. By the mid-2030s, multiple giant deep space network dishes will have to listen together just to catch a whisper. And then, sometime in the early 2030s, perhaps 2036, the final watt will slip away. The plutonium heart will give its last beat. The radio voice will fall quiet. Voyager 1 will not simply die. It will transform. Even when its voice fades, its journey won't end. With no friction in the vacuum of space, Voyager 1 will coast eternally at 17 kilometers per second. It needs no fuel, no power, no commands. Gravity and momentum will carry it for billions of years. It will become a silent witness, a ghost ship carrying the golden record into the galaxy. That golden phonograph record, fastened to its side, contains 115 images, sounds of Earth, music from cultures around the world, and spoken greetings in 55 languages. A time capsule meant for whoever might find it, though that moment, if it ever comes, lies tens of thousands of years in the future. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of a star called Gliese 445. It won't stop. It won't turn. It will simply drift past, a silent messenger from a distant blue planet, and it will keep going. Long after Earth has changed, long after our sun has aged, long after humanity itself may have fallen silent. The aging of Voyager 1 is not a failure. It is the inevitable physics of deep space. Every shutdown, and every clever software patch, every revived thruster has bought more time for humanity's most distant ambassador. Its slow fade is the price of 49 years of unbroken service and the quiet beginning of an eternal voyage. Voyager 1 doesn't know it's dying, but if it did, it would still press onward. That's what it was built to do. It doesn't dream of rest. It doesn't fear the coming silence. It simply continues, because continuing is what it was made for. Even when its voice fades, its journey won't end. It will become a silent witness, carrying our greeting to the stars. Proof that something we built with 1970s technology could outlast our own lifetimes, outlast entire civilizations, and keep traveling long after we ourselves have fallen quiet. Its final act is not an ending. It is a transformation. From an active explorer into an immortal artifact, a drifting testament that humanity once reached out with open hands and open minds,